All right, good evening, geometry students. Today we're going to be looking at something that is probably entirely new to you. There are some rules and several examples that go along with it, so the notes may be a little bit long, okay? But as you know, some days are longer, some days are shorter, and there's plenty of days that we don't even have any notes at all. So don't complain about it. Could be worse. Let's get started. Okay, our objective for this day will be the student will learn the properties and rules for what are called the special right triangles. Have no idea what the date for this will be. I anticipate it will be the Thursday following Thanksgiving, but we'll play it by ear. You may leave the date blank and fill it in at a later time. As always, press pause anytime you need more time, and then hit play when you're ready to move on. Okay, now there are two right triangles that are referred to as the special right triangles. They're called special since their angle measurements and their side lengths follow certain formulas. Now, we've already seen, there's nothing really special about that. We've seen formulas that control angle measurements based on side lengths and side lengths based on angle measurements and stuff like that. Okay, but these are a little bit more special because you require actually less information than, say, something like Pythagorean theorem would. So we'll be able to solve these triangles even with triangles that do not have enough information for Pythagorean theorem to work. Now their names described their angle measurements, and there are two. Okay, the first triangle is the 45, 45, 90, which is referring to the three angle measurements inside of the triangle. You have a 45-degree angle, another 45-degree angle, and obviously a 90-degree angle. Since we already called it a special right triangle, there needs to be a right angle in there. Okay. The second triangle that we are going to look at is referred to as the 30, 60, 90. Okay, and these are the special right triangles. And again, the angle measurements, or the name refers to the angle measurements. So the second one has a 30-degree angle, a 60-degree angle, and of course a right angle. Okay, so let's take a look. The 45, 45, 90 special right triangle has the following properties. As we already stated, it has two 45-degree angles and a right angle. Okay, so if we were to build a 45, 45, 90, it might look something like this diagram right here. Okay, two angles that are 45. We can put some angle congruency marks on them because they obviously are congruent. And further, okay, we know that since two of the angles in the triangle are congruent, then that means that the sides across from them must be congruent as well. Those guys are the legs of the triangle, so you can actually add in, you don't have to draw a separate diagram, but you can add in those tick marks into your previous diagram, and of course mark those the legs. Okay, so there is the basic 45, 45, 90 right triangle. Okay. Now, our two legs obviously are going to have the same length because they are congruent. Our triangle is going to be isosceles because of the two 45-degree angles. Okay, so whatever one of the legs measures, the other leg is going to measure also. And of course, just like in our discussions of Pythagorean, the hypotenuse is always going to be across from the right angle. Okay, so there is our hypotenuse. Please mark that on your diagram as well. Okay. Now there is a one governing rule that controls all of the side lengths in a 45, 45, 90 right triangle, and that rule says the hypotenuse equals whatever the leg is times the square root of 2. So wherever you write this formula down, please also draw the triangle that you see there, a 45, 45, 90 that has x and x for its legs and x root 2 for its hypotenuse. Okay, so let's take a look at a couple of examples dealing with the 45, 45, 90. Okay, here is one. We have a 45, 45, 90. We have some side information. some missing side information, and a hypotenuse that we are supposed to find. Solve for x. Okay. So let's have a look. I have already given away that our hypotenuse is what is missing, and our triangle is a 45, 45, 90. Okay, so our rule that we have is going to apply. Okay, now which side is missing, a leg or a hypotenuse? I've already given it away twice. It is the hypotenuse that is missing in this particular case. Okay, so it's the hypotenuse that is missing. So when we plug into our rule, we will make sure that we plug in correctly. Now the rule says hypotenuse equals leg root 2. I want to see this rule written down on your paper, not just in your notes, but anytime you use it on one of your worksheets or tests. Okay, so hypotenuse equals leg root 2. The hypotenuse is x. That is the side that we are searching for. The leg, however, is 7. Well, lucky for us, when you plug into this formula, look how easy that was. X was the hypotenuse, the leg was 7. When you plug in there, x is isolated. Our hypotenuse is 7 root 2. Very, very simple when it is the hypotenuse that is unknown. Well, what happens if it's a leg that's unknown? Let's have a look at that. Okay, here we have another triangle. We have all kinds of missing information in this triangle. So let's have a look at it. Now, one of the things that we need to keep in mind is that the rule for a 45, 45, 90 right triangle only applies if you happen to have a 45, 45, 90. So we'd probably better verify that first and foremost. Now, we have the three angles in the triangle, and they all have information about A in them. But what is it that we know about the three angles in a triangle? Okay, the three angles in a triangle should add together to equal 180 degrees. So whatever A is plus whatever A is again plus whatever 2 times A is equals 180. Well, we got a whole lot of like terms over on the left side of the problem. A plus 2 A's is 4 A's. Okay, so we have 4 A's equaling 180 degrees. We do not want 4 A's, we only want 1. So we would divide both sides by 4, and we would find that A is 45. Does that make it a 45, 45, 90? Yeah, when you plug back into your triangle, that's going to give you a 45 and a 45 on the lower sides of the lower angles of that triangle, and then 2 times 45 on the top angle of that triangle, which would be 90. So it is a 45, 45, 90. Now, in this particular case, what are we missing? Are we missing a leg or the hypotenuse of the triangle? Okay. Well, remember, you now know how big the angle measurements are, so we ought to be able to find the hypotenuse pretty easily. The hypotenuse is going to be the 7. It's going to be across from the 90 degrees. So it's not the hypotenuse that's missing this time. It is the leg of the triangle that's missing this time. Okay, so let's plug into our formula. Our formula for a 45, 45, 90 says the hypotenuse equals the leg times the square root of 2. Okay, well, plugging in what we know, our hypotenuse is 7. Our leg is unknown, the x. Okay, now this develops a little bit of a different problem for us. We want to isolate our x. X is being multiplied by the square root of 2. So to undo that, we would divide both sides by the square root of 2. That would cause this, 7 divided by the square root of 2. Okay, well, a little bit of a new problem pops up. Let's keep looking. Okay, it is considered generally to be bad mathematical format to leave a radical in the denominator of a fraction of an answer. Okay. Now, many times, as you will discover through your travels in mathematics, usually what you do, if you find something in a denominator that you do not like, in order to rid yourself of it, you actually multiply the denominator by the exact same thing. That seems to be a little bit counterproductive, but you'll see what I'm talking about here in a moment. So what we've got going on is we have a square root of 2 in the denominator that we don't like. So we are going to hit the denominator with another square root of 2, And the rule with fractions is whatever you do to the denominator, you must also do to the numerator to keep the fraction true. So our 7 over square root of 2, we don't like the square root of 2 in the denominator, so we're going to multiply it by another square root of 2. We'll do the same thing to the denominator, and look what happens. Okay, you get 7 square root of 2 in the numerator, and you get square root of 4 in the denominator. And we know well that the square root of 4 is a nice, neat whole number. What whole number is it? The square root of 4 is 2. There is your missing leg of your triangle. 7 square root of 2 divided by 2. That is your x value. Now we should be familiar from our discussions on Pythagorean theorem that sometimes with these guys we're just going to end up with side lengths that have radicals in them. And there's another example. Okay, now moving on, our other triangle is called a 30, 60, 90, and it has the following properties. Okay, so draw you a 30, 60, 90, and let's start adding some information into it. Okay, now we know from our previous discussions that the smallest angle and the smallest side are always across from each other. Okay, and so that means that in this case we have two legs, two sides that are building the right angle, and they are going to be different lengths from each other, okay, or compared to each other because we have different angle measurements in the triangle. Okay, so across from our 30-degree angle is what we're going to call the short leg. He is the short leg because he's across from the smaller of the two angles across from the legs. Okay, so mark short leg in your picture. We are also going to have a long leg in our triangle. He is going to be across from the 60-degree angle. Okay, so mark that one in your picture as well. And of course, we still have our friend, the hypotenuse, and he is always across from our right angle. So please mark that one in our picture as well. Okay. Now, there are actually two rules to go along with the 30, 60, 90s. It's not quite as simple as the 45, 45, 90 because the 45, 45, 90 only had two different side lengths. 30, 60, 90 has three different side lengths. Okay, so the two rules are, first off, the hypotenuse is always twice as big as the short leg. Hypotenuse equals 2 times the short leg. Long leg, a little bit more complicated, is the short leg times the square root of 3. Okay? So if you mark that information in your picture, your short leg should be x, your long leg should be x root 3, and your hypotenuse should be 2x. Now, if you do the quick little mental calculations on that, that means everything in a 30, 60, 90 is based upon the short leg. If you know the short leg, then you know everything in the triangle. Okay, so let's look at a couple of examples going along with 30, 60, 90. Okay. Copy this triangle down real quick. Obviously, this time we have two different missing side lengths. We have x and y that we need to solve for. Okay, so we'll take them one at a time. As before, it does not necessarily mean you solve them alphabetically. You solve for anything that you can possibly get your hands and your brain wrapped around. And if that means you can get x first, then get it. If you can get y first, then get it. Okay, so let's have a look. Okay, always verify that your triangle is actually 45, 45, 90 or a 30, 60, 90 if you're going to use those rules. Okay, so this one is a 30, 60, 90, so we'll make sure we use the 30, 60, 90 rules. You do not want to reuse these rules on a triangle that is not the correct kind of triangle. Okay, so let's see what we can do here. Let's take a look at x. What kind of a side length is the side that is marked x? Is it a short leg or a long leg or a hypotenuse? It is the hypotenuse. It is across from the right angle. Okay, so let's see if we can find a rule that talks about the hypotenuse. Okay, the rule says hypotenuse equals 2 times your short leg. Okay, well, we already know the hypotenuse is x, and which of these two values is the short leg? Is it the 5 or is it the y? Well, our basic rule said that the short leg is always across from the small angle, the 30-degree angle, so our short leg is 5. So we have x equals 2 times 5. 2 times 5 is obviously 10. There is your hypotenuse. Okay, so we also need to find the other missing side, the y. Okay, so what kind of a side is y? Well, it should be pretty much a giveaway at this point. We've talked about hypotenuse and short leg. The one we have not talked about is the long leg. It is the long leg. The long leg is always across from the 60-degree angle. Okay, so we know for a fact it is the long leg. So we'll look at our 30, 60, 90 rules. We will select a rule that talks about the long leg, and the rule says long leg equals short leg times the square root of 3. Okay, so let's plug in what we know. Our long leg is y, and our short leg is 5. Well, that was easy. When we plugged in everything, there was nothing left to simplify. 5 square root of 3 is as simple as it gets. We don't need to go to our calculator and get some ridiculous decimal point. We leave it as a radical, and we are done right there. So as you can see, when you are given the short leg, these problems are very, very simple. The real challenge will be what happens when they do not give us the short leg. Okay, so let's have a look at this triangle. A lot of information floating around in this triangle and a lot of missing information in this triangle. So this one's liable to be a little bit of a challenge. Okay. Well, before we go charging headlong into using any of the 45, 45, 90 or 30, 60, 90 rules, you had better make sure that it is actually one of those triangles. Do not use these rules on a triangle that is not 30, 60, 90 for the rules we're talking about now, or 45, 45, 90 for the rules we talked about earlier. Okay, so is it a 30, 60, 90? Well, when we look at the angles that are in the triangle, we see an x, we see a 2x, and we see a 3x. Well, that's not very helpful, but we do have a rule for triangles, is the three angles in a triangle should add together and be supplementary. So let's have a look at that. We have 1x's, we have 2x's, we have 3x's. That is 6x's. 6x's equal 180 degrees. Obviously, we don't want 6x's, we only want 1, so we'll divide everything by 6, and x is 30. If that's the case, we have a 30-degree angle up at the top. At the lower left, we have a 60-degree angle, and the lower right, we have a 90-degree angle. So yes, we do have a 30, 60, 90. So yes, we may use these rules to try to find out what's going on with y and z. All right, so let's take a look. Let's see what we can figure out first. Okay, how about y? Let's see if we can find out y. Okay, well, what kind of a side length is y? Is it the short leg, the long leg, or the hypotenuse? Okay. Obviously, the y this time is the hypotenuse. It is across from the right angle. So we're going to look at our rules, and we will pick out a rule that talks about the hypotenuse. And the rule says the hypotenuse equals 2 times the short leg. Well, when we take the information out of the triangle and try to plug in, we're going to need the short leg in order to find the hypotenuse. And we do not have the short leg either. Okay, so looking at y first did not make any sense. So let's look at other information. Let's check out z instead. Okay, so that formula didn't work. We only have one other rule that we can work with. Okay, but looking at z, z is the short leg because it is across from the 90-degree or the 30-degree angle. Okay, so this time the other rule we would be looking at is trying to not get from the short leg to the hypotenuse, but this time from the short leg over to the long leg. And the rule says long leg equals short leg times square root of 3. Now plugging in the information that we have from the picture, the long leg is 5 and the short leg is z. Okay, now our z is being multiplied by the square root of 3. We don't want it multiplied by the square root of 3. We want it by itself. So that would make us divide both sides by the square root of 3. That would give us 5 divided by the square root of 3 on the left. And once again, it's considered bad format to leave a radical in an answer. So we're going to get that radical out. Do you remember how we do it? We're going to multiply by exactly the thing that we do not like. So we're going to hit that denominator with another square root of 3. And whatever we do to the denominator, we have to do the same to the numerator. So the numerator of the fraction is going to be 5 square roots of 3, and the denominator is the square root of 9. Now, the square root of 9 is a nice, neat whole number, and that is 3. Okay, so we have 5 square root of 3 over 3 is z. Okay, it's an ugly number, but it is the correct one. Okay, so going back to the problem, here's what we know now. The short leg is 5 square root of 3 over 3. And that leaves us only with y. Now, we've already had the discussion about y, and we had a problem that said the hypotenuse equals 2 times the short leg. We were not able to solve it earlier because we did not know the short leg. Well, now we do. Okay, so let's see what happens now. We have a 2 times 5 square root of 3 over 3. Now that 2 is in the numerator. Remember, everything is a fraction, even if it is not written like one. So that is 2 over 1 times 5 square root of 3 over 3. So numerators with multiplication are going to go get other numerators. So the 2 is going to go get another whole number in the numerator, which is the 5. 2 times 5 is 10. Square root of 3 is unchanged. The only thing that would mess with a square root by multiplication is another square root. It did not have another one to mess with it, so it's still sitting there. And the 3 in the denominator, it would have been affected by another denominator, and we did not have one. So the 3 is unchanged. Okay. So you have solved for x, which was our angle measurements. You have solved for y, which was our hypotenuse, and you solve for z, which was our short leg. Okay, again, another ugly number, but it is the number. Okay, I have a worksheet on my slide. Did not intend for that to be there. Should have been a blank screen. But anyway, I do not have any sample problems for you to work out here tonight. This is a little bit too complicated. I don't want you trying any on your own. We'll get some more examples in class on the following day. Sorry the notes ran a little bit long, but as you know, sometimes they're long, sometimes they're short, sometimes we don't have any at all. So take the good with the bad, and I will see you in class.